Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle and we have chord AD or string AD that equals to 10 units. Chord or string BC equals to 5 units, and the center of this circle is at point O, and this is a right angle. It equals to 90 degrees, and we want to find out the radius of this circle. First of all, I will explain you what is a peripheral angle. A peripheral angle is an angle inside the circle its vertex is on the circle, and its columns are chords in the circle, or its columns are strings in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle, and its columns are chords or strings in the circle. Okay, in order to clarify the issue of a peripheral angle, I will give you an example of a peripheral angle. So actually angle alpha is a peripheral angle because first of all it is inside the red circle, and its vertex the vertex of angle alpha is at point A, and point A is also a point on the circle itself, and the curve AB of angle alpha is string or chord in the circle, and also curve AC of angle alpha is chord or string in the circle. For that reason, angle alpha is a peripheral angle. Okay, so I'll repeat again on the definition of a peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are chords in the circle. Okay, as you can see here, angle alpha is inside the red circle. The curve, the vertex of angle alpha is at point A, and point A is a point on the circle itself, and the curve AB or curve AB of angle alpha is a string or chord in the circle, and also curve AC of angle alpha is a string or chord in the circle. For that reason, angle alpha is a peripheral angle. Okay. So now we will draw a chord or a string through points A and O. Point O is the center of this circle. Okay. We will call to the touching point between the string that I drew and the circle point M. Again, point M is the touching point between the circle and the string that I drew. And actually, chord AM or string AM that I drew is the diameter of this circle. I'll write it down. Chord AM or string AM that I drew is the diameter of the red circle. Because it passes through the center of this circle that is to say it passes through point O, that is the center of the circle. So I will read again what I wrote. Chord AM is the diameter of the red circle because it passes through the center of the circle. That is to say, it passes through point O, that is the center of the circle. As I have already mentioned, point O is the center of this circle, and the chord AM that I drew passes through point O, that is the center of this circle. For that reason, chord AM or string AM is the diameter of this circle. Any string or any chord that passes through the center of a circle is defined as the diameter of that circle. And chord AM passes through point O, that is the center of this circle. For that reason, chord AM is the diameter of this circle. Okay? In the next step, we will connect together points M and D by a straight line. Okay, we connected together points M and D by a straight line. Actually, we have a rule. I will call it rule number 1. According to rule number 1, a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will read again rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will show you an example of rule number 1. Suppose that string AB or chord AB is the diameter of this red circle. So any peripheral angle that rests on chord AB, that is the diameter of this circle, will be equal to 90 degrees according to rule number 1. So if, for example, we have the peripheral angle as you can see from the drawing, peripheral angle ACB rests on chord AB or on string AB, that is the diameter of the red circle, of this red circle. So according to rule number 1, it equals to 90 degrees. Okay, so because of the fact that peripheral angle ACB rests on chord AB, and chord AB is the diameter of this circle, peripheral angle ACB equals to 90 degrees. So I will write here 90 degrees. Peripheral angle ACB or BCA equals to 90 degrees because of the fact that it rests on chord AB or on string AB, that is the diameter of this circle. So according to rule number 1, peripheral angle ACB equals to 90 degrees. Okay, so I will write it down. Angle ACB rests on chord AB, and chord or string, it is the same. Chord AB is the diameter of the circle, so according to rule number 1, it equals to 90 degrees. So I will read again the things that I wrote. Chord ACB rests on angle, peripheral angle ACB rests on chord AB, and chord AB is the diameter of the circle. So according to rule number 1, it equals to 90 degrees. So actually, peripheral angle ACB rests on chord AB, and chord AB is defined as the diameter of this red circle. For that reason, according to rule number 1, peripheral angle ACB equals to 90 degrees. Okay? So we can use rule number 1 in our circle, or we can implement rule number 1 in our circle Actually, angle ADM, it is actually peripheral angle ADM rests on chord AM on chord AM or string AM, it is the same. Chord AM, that is the diameter of the circle. Chord AM is the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. So actually peripheral angle ADM equals to 90 degrees according to rule number 1. I will read again what I wrote. And peripheral angle ADM rests on chord AM, that is the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. Okay, peripheral angle ADM rests on chord AM, that is the diameter of this circle. For that reason, according to rule number 1, peripheral angle ADM equals to 90 degrees. Okay. In the next step, we will focus on the right triangle ADM. And we will define angle AMD as alpha. Angle AMD equals to alpha according to our definition. And angle MAD will be equal to beta. So, in the right triangle AMD, right triangle AMD or ADM, it is the same. Angle AMD equals to alpha. Angle AMD equals to alpha. Angle AMD equals to alpha. And angle MAD equals to beta. Angle MAD equals to beta, according to our definition. As you have already know, the sum of the angles in any triangle equals to 180 degrees. and especially it is true in the right triangle ADM, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. So I will write it down, and that will be our first equation. Alpha plus beta plus 90 degrees, that is actually the sum of the angles in the right triangle ADM, equals to 180 degrees. And it is actually true for all the triangles in the world. The sum of any triangle in the world equals to 180 degrees. Okay, so equation number 1 states that the sum of the angles in the right triangle ADM equals to 180 degrees. The sum of its angles is alpha plus beta plus 90 degrees, and it equals to 180 degrees. Alpha plus beta plus 90 degrees equals to 180 degrees. That is our first equation. Now we will subtract 90 degrees from the first equation. We will get that alpha plus beta equals to 90 degrees. So we subtracted 90 degrees from equation number 1. Actually, alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we'll subtract alpha from equation number 1. So we subtracted alpha from this equation. Alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals 90 degrees minus alpha. So from equation number 1, we got the equality that beta equals to 90 degrees minus alpha. Okay. In the next step, we will connect together points A and B by a straight line. Actually, we have a rule number 2, that states, rule number 2, that peripheral angles that rests on the same chord or the same string are equal to each other. Actually, it is peripheral angles that rests on the same chord or the same arc are equal to each other. Okay? So I write it down. So I will read rule number 2 again. Rule number 2 states that peripheral angles that rest on the same chord or same arc are equal to each other. Okay, so now I will show you an example of rule number 2 in order to clarify it. Actually, if we have two peripheral angles that rest on the same chord, the same arc, for example, we have peripheral angle alpha we have peripheral angle alpha that rests on chord BC. Peripheral angle alpha rests on chord BC, and we have another peripheral angle beta that rests on the same chord BC, as you can see from the drawing. Peripheral angle beta rests on the same chord BC. Chord BC or string BC, it is the same. So, because of the fact that those two peripheral angles, alpha and beta, rest on the same chord BC, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay, so I write it down. So because of the fact that those two peripheral angles rest on the same chord, that is to say chord BC, according to rule number 2, They are equal to each other. That is to say, alpha equals to beta, or peripheral angle alpha equals to peripheral angle beta. So I will read again the things that I wrote. Because of the fact that those two peripheral angles rest on the same chord, that is to say chord BC, as you can see from the drawing, peripheral angle alpha rests on chord BC, and also peripheral angle beta rests on the same chord BC. So according to rule number 2, they are equal to each other, that is to say alpha equals to beta. Okay, alpha equals to beta because of the fact that those two peripheral angles rest on the same chord BC. Okay, actually we can implement rule number 2 in our circle. Angle AMD equals to alpha. Angle AMD equals to alpha. And angle AMD that equals to alpha rests on chord AD. Okay, angle AMD equals to alpha and it rests on chord AD. Again, angle AMD equals to alpha and it rests on chord AD. And angle ABD, all the angles are peripheral angles, of course. Angle ABD or peripheral angle ABD also rests on chord AD. Angle ABD rests also on chord AD. So we have two angles that rest on the same chord. Angle alpha rests on chord AD and also angle ABD rests on the same chord AD. So according to rule number 2, they are equal to each other. That is to say, angle ABD equals to alpha. So I read again the fix that I wrote. Angle AMD equals to angle alpha, and angle AMD that equals to alpha rests on chord AD, and angle ABD also rests on the same chord AD. So because of the fact that those two angles, those two peripheral angles rest on the same chord AD, according to rule number 2, they are equal to each other. That is to say, this angle equals to this angle, or angle ABD equals to angle alpha, because of the fact that both those two angles rest on the same chord AD, according to rule number 2. Because of this fact that those two peripheral angles rest on the same chord AD, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha. Okay? So I'll read again the things that I wrote. Angle AMD equals to alpha, and it rests on chord AD. Okay? Angle AMD equals to alpha, and it rests on chord AD. While angle ABD also rests on the same chord AD. Angle ABD rests on the same chord AD. So, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha, because of the fact that both those two peripheral angles rest on the same chord AD. For that reason, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha. That's all. Okay? So, angle ABD equals to angle alpha, according to rule number 2, because of the fact that angle ABD rests on the same angle as angle alpha. So, because of the fact, according to rule number 2, they are equal to each other. That is to say, if this angle is alpha, this angle is also alpha. Okay? In the next step, we will define the vertex of this right angle as point L. Okay, the vertex of this angle that equals to 90 degrees will be equal to L. So actually angle in the right triangle BAL, angle BAL will be defined as angle X. Okay, angle BAL is defined as X. Okay, as I've already mentioned, the sum of the angles in any triangle equals to 180 degrees, and especially it is true in the right triangle ALB. The sum of its angles equals to 180 degrees. That is to say, alpha plus x plus 90 degrees equals to 180 degrees. Okay, so I will write it down. That will be our second equation. The sum of the angles in the right triangle ALB is alpha plus x plus 90 degrees equals to 180 degrees. Okay, so equation number 2 states that the sum of the angles in the right triangle ALB equals to alpha plus x plus 90 degrees. Alpha plus x plus 90 degrees, and it is equals to 90 degrees. It is true for any triangle in the world, especially in the right triangle A and B. Okay, so in the same way as we did in the right triangle AMD, we will do in the right triangle A and B. We will subtract 90 degrees from the second equation. So we subtracted 90 degrees from the second equation. Alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus x, and 180 degrees minus 90 degrees equals to 90 degrees. The next step is subtract alpha from this equation number 2. So we subtracted alpha from this equation. Alpha plus x minus alpha equals to x. 90 degrees minus alpha equals to 90 degrees minus alpha. So we got in the second equation that x equals to 90 degrees minus alpha. But as you remember, we in the first equation we actually have the equality that states that beta equals to 90 degrees minus alpha. That is our first equation. Okay, so I will write it down. According to our first equation, beta equals to 90 degrees minus alpha. Okay, so we know from the second equation that x equals to 90 degrees minus alpha, and from the first equation we know that also that beta equals to 90 degrees minus alpha. So actually we will integrate those two equations, equation number 1 and 2, into one equation in order to find out the value of x. So actually from equation number 2 we know that x equals to 90 degrees minus alpha. Okay, I copied equation number 2 here. X equals to 90 degrees minus alpha. I copied it here. X equals to 90 degrees minus alpha. Okay, I copied equation number 2 here. That is from one side, but from the other side, from equation number 1, we know that 90 degrees minus alpha equals to beta. So we can add to this equality that 90 degrees minus alpha also equals to beta according to equation number 1. Okay? So actually this is equation number 2. And this is equation number 1. Beta equals to 90 degrees minus alpha is equation number 1. And x that equals to 90 degrees minus alpha is equation number 2. So we integrated those two equations together, and from this integration we get the equality that states that x equals to beta. Okay, you can see here the equality that states that x equals to beta. Okay, okay, so x equals to beta. So actually we defined angle BAL as x, but we know that x equals to beta. Okay, x equals to beta. Okay, so we can substitute x by beta, because x equals to beta. Okay, we substituted x by beta because x equals to beta. Okay, now we have rule number 3. Rule number 3 states that peripheral angles that equal to each other rests on equal chords, or equal peripheral angles rests on equal chords. Okay, so I write it down. Rule number 1 states that equal peripheral angles rest on equal chords. Equal chords or also equal arcs actually when they rest on equal chords they must also rest on equal arcs. Okay, I will explain rule number 1. First of all, I will read it again. Rule number 1 states that equal peripheral angles rest on equal chords or equal arcs. Okay, so I will explain rule number 3 by an example. If we have two peripheral angles that are equal to each other, for example, we have peripheral angle alpha, peripheral angle alpha rests on chord BC. Okay, again, peripheral angle alpha rests on chord BC. And we have another peripheral angle alpha okay, the peripheral angle alpha in the red color rests on chord EF. Okay, peripheral angle alpha in the red color rests on chord EF, and peripheral angle alpha in the blue color rests on chord BC. Okay, we have two peripheral angles that are equal to each other, both of them equal to alpha. So according to rule number 3, they rest on equal chords. Angle alpha rests on chord BC. The angle alpha in the blue color rests on chord BC. And angle alpha in the red color rests on chord EF. according to rule number 3, equal peripheral angles rest on equal chords. That is to say, BC equals to EF. Okay, because of the fact that those two peripheral angles are equal to each other, both of them equal to alpha, they also rest on equal chords. That is to say, BC equals to EF. So equal peripheral angles, this angle is alpha and this angle is also alpha, rest on equal chords. That is to say, BC equals to EF. Okay? We have two equal peripheral angles. This angle equals to this angle. So they also rest on equal chords. That is to say, this chord equals to this chord because of the fact that this angle equals to this angle. Also, according to rule number 3, this chord equals to this chord. Okay? So I'll write the things that I explained. So, because of the fact that those two peripheral angles equal to each other, so I read what I want. Because of the fact that those two peripheral angles are equal to each other, both of them equal to alpha, they also rest on equal chords. That is to say, BC equals to EF. Okay, those two peripheral angles are equal to each other. So, according to rule number 3, they are also rest on equal chords. That is to say, BC equals to EF. So, because of the fact that those two angles are equal to each other, they rest on equal chords. That is to say, BC also equals to EF. Okay? So we can implement rule number 3 in our circle. As you can see from the drawing, we have two peripheral angles that equal to each other. Both of them equal to beta. Okay, both those peripheral angles equal to beta. So according to rule number 3, they also rest on equal chords. That is to say, BC equals to MD. Because of the fact that the angles equal to each other, they also rest on equal chords. That is to say, BC equals to MD. Okay? So, I will write it down. Because the peripheral angles are equal to each other, both of them equal to beta, according to rule number 3, they also rest on equal chords. Okay? So, this beta angle rests on chord BC, and this beta angle rests on chord MD, and according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? That is to say, BC equals to MD. So I will read again the things that I wrote. Because the peripheral angles are equal to each other, both of those peripheral angles equals to beta. According to rule number 3, they also rest on equal chords. This peripheral angle beta rests on chord BC, and this peripheral angle beta rests on chord MD. And according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? That is to say, BC equals to MD. So because of the fact that those two peripheral angles are equal to each other, both of them equal to beta, they also rest on equal chords. That is to say, BC equals to MD. Okay? So actually BC equals to MD, but we have already know that BC equals to 5 units. According to the question, it is given us that BC equals to 5 units. According to rule number 3, we arrive to the conclusion that BC equals to MD. But it is given us in the question that BC equals to 5 units. So we can add to this equality that BC equals to 5 units according to what is given us in the question. Okay, we know that BC equals to 5 units, so we can add to the equality that we arrived, we concluded that BC equals to MD according to rule number 3, and we have already know it is given us that BC equals to 5 units. Okay, so we can deduce from this equality that MD also equals to 5 units. MD also equals to 5 units. Okay, MD also equals to 5 units. So we can write here that MD equals to 5 units. MD equals to 5 units. Now I will draw right triangle AMD again. So this is right triangle AMD. Side AB equals to 10 units, side MD equals to 5 units. And actually the hypotenuse of the right triangle AMD is AM. And we know that the AM is the diameter of this circle. So we can write here that AM is actually D, it is the abbreviation for diameter. Okay, Here we can use the Pythagorean theorem in order to find out the value of D. Okay, so according to the Pythagorean theorem, in a right triangle, the Pythagorean theorem applies only on right triangles. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I'll read again the Pythagorean theorem. In a right triangle, the Pythagorean theorem apply only on right triangle. If it is not right triangle, you cannot use the Pythagorean theorem. In a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we can implement the Pythagorean theorem in our right triangle. The square of the hypotenuse is am squared. This will be our third equation, am squared equals to the sum of the squares of the perpendiculars, equals to ad squared plus md squared. Okay, so third equation states that the square of the hypotenuse, that is to say am squared, equals to the sum of the square of the perpendiculars, equals to ad squared plus md squared. Okay, equals to ad squared plus md squared. But we know that am equals to d, ad equals to 10 units, and md equals to 5 units. Okay, so we can actually put the data in equation number 3. Okay, we know that AM equals to D, AD equals to 10 units, and MD equals to 5 units. So we can substitute AM by D, and we can substitute AD by 10 units, and we'll substitute MD by 5 units. So we got that D square equals to 10 square plus 5 square. 10 square is 100 and 5 square is 25, so 100 plus 25 equals to 125. So I write it down. So we got that D square equals to 125. So this is our further question that states that D square equals to 125. So we will take a root out of equation number 3. We'll get that T equals to the root of 125. Okay, we took the root out of equation number 3, we got that D equals to the root of 125. 125 equals to 25 times 5, so I write it down. So we got that D equals to the root of 25 times 5, because 25 times 5 equals to 125. Now we can separate the root to two roots according to the rule that the root of A times B equals to the root of A times root of B. So according to the rule that the root of A times B equals to the root A times root B, we can separate this root to two roots. Okay, it will be equal to the root of 25 times root of 5, according to this rule. So here we separated the root of 25 times 5 to two roots, to the root of 25 times root of 5, according to the rule that the root of AB equals to the root of B, to the root of A times root of B. Okay, and we know that the root of 25 is 5, so I will write it down. So the root of 25 is 5, so we got that d equals to 5 times root 5. Okay, but we know that the diameter of any circle equals to 2 times the radius of the circle, so we can create our fourth equation that states that the diameter of this circle equals to 2 times the radius of the circle. Okay, it is true for any circle, especially in our circle. The diameter of our circle equals to 2 times the radius of the circle. Okay, our fourth equation states that the diameter of the circle equals to 2 times the radius. It is true for any circle, especially to our circle. But we know that d, the diameter of the circle, equals to 5 times root 5. So we can substitute d by 5 times root 5 because d equals to 5 times root 5. So we substitute d by 5 times root 5 because d equals to 5 times root 5. Now we will divide equation number 4 by 2 and we will get the radius of the circle. So we divided equation number 4 by 2 and we got that the radius of the circle equals to 5 times root 5 over 2, or in terms of numbers you can write that the radius of the circle equals to 5.59 units. Okay, the radius of the circle equals to 5 times root 5 over 2 units, or in terms of numbers, the radius of the circle equals to 5.59 units. Okay, the radius of this circle, the red circle, equals to 5.59 units, so we can say also that the radius of this circle equals to 5 times root 5 over 2 units. Okay, now I will summarize the lecture. Actually, we wanted to find the radius of the red circle and we actually know that the string AD or chord AD equals to 10 units, chord BD of the circle equals to 5 units, and the center of the circle is at point O, and this angle is 90 degrees, and we want to find out the radius of this red circle. Okay. First of all, we define the term peripheral angle. Actually, peripheral angle is an angle inside the circle. Its vertex is on the circle, and its curves are strings in the circle. So I will read you the definition of a peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle, and its curves are chords in the circle. Its curves are chords or strings in the circle. So actually, we have an example of a peripheral angle alpha. Or we can say that alpha is a peripheral angle because first of all it is inside the circle, inside the red circle. Then the vertex of angle alpha is at point A, and point A is a point on the circle itself, and chord AB of angle alpha, or string, or actually curve AB of angle alpha is chord in this circle, or string in this circle, and also curve AC of angle alpha is chord or string in the circle, and also angle alpha rests on chord BC. Okay, so that is an example of a peripheral angle. Again, a peripheral angle is an angle inside the circle. Angle alpha is inside the red circle. Its vertex, the vertex of angle alpha is at point A, and point A is a point on the circle, and its curves, curve AB of angle alpha is string in this circle, and also curve AC of angle alpha is string in this circle. Okay. In the next step, before that, we defined point O is the center of this circle. Okay, and actually in the next step connected points M and O, or actually we drew a string through points, we drew a string through points A and O, and we called to the touching point between the circle and the chord that we drew point M. Okay, you should remember that chord AM passes through point O, that is the center of this circle. Okay, and actually chord AM that we drew is the diameter of the circle, of the red circle, because it passes through the center of this circle, and any string or chord that passes through the center of the circle is defined as the diameter of the circle. For that reason, chord AM is the diameter of this circle. Okay? And we connected together points M and D by a straight line. We have actually rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So actually, if we have suppose that string AB is the diameter of the red circle, and we have peripheral angle ACB that rests on chord AB. So according to rule number 1, it equals to 90 degrees, because any peripheral angle that rests on the diameter of the circle, and AB is the diameter of the circle, equals to 90 degrees. Therefore, because of the fact that peripheral angle ACB rests on the diameter of the circle, that is to say on chord AB, it equals to 90 degrees according to rule number 1. Okay? So now we focus on the right triangle ADM. We know that this angle is 90 degrees. We define angle AMD is alpha and angle MAD is beta, and we actually know that the sum of the angles in any triangle equals to 180 degrees, and especially in the right triangle ADM, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. And this is our first equation. Alpha plus beta plus 90 degrees equals to 180 degrees. And we got that beta, angle beta equals to 90 degrees minus alpha. Okay. Then we connected together points A and B by a straight line, and we have rule number 2 that states that peripheral angles that rest on same chord or same arc are equal to each other. And we add the example of rule number 2. We have two peripheral angles, alpha and beta, that rests on the same chord BC. So according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay, so actually we used rule number 2 in our circle. Use the rule number 2 in our circle. angle AMD rests on chord AD and it equals to alpha. Angle AMD equals to alpha and it rests on chord AD. And angle ABD rests on the same chord AD. So according to rule number 2, if we have two peripheral angles that rest on the same chord, then they are equal to each other. So this angle ABD that rests on chord AD equals to alpha, because alpha also rests on the same chord AD. Okay, so angle ABD equals to alpha according to rule number 2, because both angle alpha and angle ABD rest on the same chord AD. So according to rule number 2, angle ABD also equals to angle alpha that rests on chord AD. Okay, so angle ABD equals to alpha according to rule number 2. And we actually in the right triangle ALB, we defined angle BAL that it equals to x, and we know that the sum of the angles in the right triangle ALB equals to 180 degrees, so alpha plus beta plus 90 degrees equals to 180 degrees. So second equation was that alpha plus x plus 90 degrees, that is the sum of the angles in the right triangle ALB, the sum of the angles equals to 180 degrees. Okay, so for our second equation we got that x equals to 90 degrees minus alpha. But for our first equation we know that beta also equals to 90 degrees minus alpha. So we integrated these two equations to one equation because x that equals to 90 degrees minus alpha, it is written here. This is equation number 2. X equals to 90 degrees minus alpha is equation number 2. And 90 degrees minus alpha that equals to beta, 90 degrees minus alpha that equals to beta is equation number 2. So this equality is the integration of equation number 1 and 2 together. And from this integration, we can deduce that x equals to beta. Okay, x equals to beta. Okay, x equals to beta, so we can substitute angle x by beta. So angle BAL, instead of x, we can write beta because x equals to beta. Okay, so we have also rule number 3 that states that equal peripheral angles rest on equal chords. And actually we have here equal peripheral angles, both those angles equal to angle alpha, and according to rule number 3 they rest on equal chords, that is to say BC equals to EF. Okay, equal peripheral angles, they are equal to each other because both of them equal to alpha. They also rest on equal chords, that is to say BC equals to EF. Okay, so this is the explanation for rule number 3, and we actually implemented rule number 3 in our circle, because we have here two peripheral angles that both of them equals to beta. Both two peripheral angles equals to beta. So according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay, so because of the fact that those two peripheral angles are equal to each other, both of them equal to angle beta, they also rest on equal chords. That is to say, BC equals to MD, according to rule number 3. Okay, so we got from rule number 3 the equality that states that BC equals to MD. So BC equals to MD according to rule number 3, but we already know from the question it is given us, we know that BC equals to 5 units, it is given us in the question. So we can add to this equality that BC equals to 5 units according to what is given us in the question. Okay? So we can deduce from it, of this equality, that MD equals to 5 units. Okay, MD equals to 5 units. So we can write here that MD equals to 5 units. And actually I draw the right triangle AMD again. We know that side AD equals to 10 units, side MD of this right triangle equals to 5 units, and AM is the diameter of the circle. AM is the diameter of the circle according to what we found out in the beginning of the lecture. So we can name AD, we can name AM by D because it is the abbreviation for diameter, and we can use the Pythagorean theorem in order to find out the value of D. And the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the Pythagorean theorem is correct only on right triangles. So the square of the hypotenuse in a right triangle equals to the sum of the squares of the perpendiculars. So we can implement the Pythagorean theorem in our right triangle AMD, and we can say that AM squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AD square plus MD square. Okay, so that is actually our third equation. AM squared, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AD square plus MD square. But we know that AM equals to D, AD equals to 10, and MD equals to 5, so we can put the data in question number 3, and we actually got that D square equals to 10 square plus 5 square. And in the final process of this third equation, we got that that D equals to 5 times root 5. Okay, D equals to 5 times root 5 units. That is the diameter of the circle, but we know that the diameter of any circle equals to 2 times the radius of the circle. It is true for every circle in the world, and especially in our circle, the diameter of this circle equals to 2 times the radius. So we created the fourth equation that states that the diameter of the red circle equals to 2 times the radius of the circle. Okay, but we know that D equals to 5 times root 5 units according to the third equation, so we can substitute D by 5 times root 5. So we substituted D by 5 times root 5, and we got that 5 times root 5 equals to 2 times the radius. We divided equation number 4 by 2, and we got that the radius of the circle equals to 5 times root 5 over 2 units. So in terms of numbers, the radius of this circle equals to 5.59 units. Okay, so the radius of the circle of this circle equals to 5.59 units, so we can also say that the radius of this circle equals to 5 times root 5 over 2 units. Okay, thank you very much.